Hello, I'm Donald Tandoy from CE3C, and I'm going to discuss what is matrices and matrix operation, and also I'm going to explain the different methods in evaluating determinants of a matrix. Matrix is a rectangular array of numbers that are usually named by a capital letters A, B, C, and so on. Each entry in a matrix is referred to as Aij, such that I represent the row while J represent the number of columns. Matrices are often referred to by their dimension, m times n, which indicates m rows and n columns. For example, may dalawa tayong matrix dito, A saka B. Yung A ay 4x3 matrix. 4x3. Bakit naging 4x3? Kasi apat yung rows. 1, 2, 3, 4. Tatlo yung column. 1, 2, 3. Ito yung pababa. Yung rows naman ay punta dun. This one is 1, 2, 3, 4. 1, 2, 3, 4. 4x4 matrix. We have special matrices. Number 1, column vector or row vector, which consists of only one column and rows. For example, this matrix A, column vector is equal to 1, -5, 8, 0. This 4x1 column vector. Matrix B is row vector 1, -5, 8, 0. This one is 1x4 matrix. Number 2, null matrix, also known as zero matrix, which element are equal to 0. All element daw ng matrix is equal to 0. Number 3, square matrix, when it has an equal numbers of rows and column. For example, A, matrix A is equal to 1, 2, 3, 4, 5, 6, 7, 9. This is a perfect example of square matrix, a 3x3 matrix. Number 4, identity matrix, which is a square matrix that all its diagonal elements are equal to 1 and all of its diagonal elements are equal to 0. For example, I equal to 1, 0, 0, 0, 1, 0. Yung diagonal daw ng identity matrix ay equal to 1 ito. And yung of diagonal naman is equal to 0. And number 5, diagonal matrix is also a square matrix whose diagonal elements can take any value. Elements that are not belong in principal diagonal is equal to 0. For example, matrix A is equal to 7 0 0 0 4 0 0 0 8. Yung main diagonal daw ay kahit anong value. 7 4 8. Yung nasa labas naman ng diagonal is equal to 0. Ito. Number 6. Scalar matrix. Sa diagonal matrix which all the diagonal entries are equal. For example, let A is equal to 2 0 0 0 2 2. Magkaiba sila nung kaninang nauna. Yung main diagonal ay 1. Ito naman maski anong number na basta pare-parehas yun sa diagonal. Number 7. Symmetric matrix is a square matrix which the corresponding of diagonal elements are equal. Malalaman daw natin na symmetric matrix kapag square matrix or yung 3x3, 4x4, 5x5 yung equal ang rows sa columns. Example, A is equal to 4 2 6 3 4 2 6 3. So kapag tinranspose ang kalalabasan nung pag-transpose yung pa rin yung column ay magiging rows, yung rows ay magiging column. Number 8. Transpose matrix which corresponding rows and columns interchange. Sabi ko nga kanina, pag magta-transpose, yung column magiging rows, yung rows magiging column. Example, 3 4 1 6 8 2 5 3 6. Kung magta-transpose is yung matrix A natin ay may nakalagay na transpose dun sa taas. Equal to itong column na to magiging rows. 3 4 1 6 ito rin 2 5 8 3 6. Ayan. Number 9. Singular matrix. It is a square matrix that is said to be singular if its determinant is 0. Example, matrix A is equal to 1, negative 1, 3, 1, 3, negative 3, 5, 3, 3. Dapat daw, determinant ito is equal to 0. Kunin natin yung determinant niya by using basket weave method. 1 times 3 times 3. is equal to 9. Negative 1 times 3 times 5 is equal to 15. 3 times 1 times 3 equal to 9. Minus, kasi dito naman tayo sa kabilang diagonal. 5 times 3 times 3 is equal to 45. 1 times negative 3 times 3 is equal to 9. Negative 1 times 1 times 3 is equal to negative 3. Next is i-add natin tong answer. 9 plus 15 plus 9 is equal to 33. Minus 45 plus negative 9 plus 3 is equal to 33. So, 33 minus 33 is equal to 0. This is a singular matrix. Dako naman tayo sa matrix operations. Adding and subtracting matrices. Addition and subtraction of matrices is only possible when the matrices have the same dimension or same ng rows saka column. Either 3 by 3 by 3 or 2 by 2 or 4 by 4 matrix. Example A is equal to 4 2 1 3 5 1 2 4 0 3 3 2 5 1 1 6. Matrix A is 4 by 4 4 by 4 matrix, and plus matrix B is equal to 0 1 4 8 3 6 5 2 4 5 3 1 6 2 1 0. This one is also 4 by 4. A plus B is equal to C. Matrix A is equal to 4 by 4. Matrix B is equal to 4 by 4 also. Pag nag-a-add tayo is yung first row, first column ng matrix A saka first row, first column ng matrix B. A plus B A plus B. First row, first column ng matrix A, saka first row, first column ng matrix B. Equal to 4 plus 0, 4 plus 0, 2 plus 1, 2 plus 1, 1 plus 4, 3 plus 8, and so on. Ganun din dito. 5 plus 3, 1 plus 6, 2 plus 5, 4 plus 2. Dire-diretso lang. 0 plus 4, 3 plus 5, 5 plus 3, 1 plus 1, 3 plus 6, 2 plus 2, 1 plus 1, 6 plus 0. Simply add lang nito. C is equal to 4 plus 0 is equal to 4, 5 plus 3 is equal to 8, 0 plus 4 is equal to 4, 3 plus 6 is equal to 9. Yun din dito. Dire-diretso lang. 3, 7, 8, 4, 5, 7, 8, 2, 11, 6, 2, 6. This is the answer. In matrix operation, adding and subtracting matrices. Addition and subtraction of matrices is only possible when the matrices have the same dimension or same rows and columns. For example, this 4x4 matrix, 4 columns and 4 rows, plus B na 4x4 din. Ito lang yung posible na pwedeng i-add or subtract. A plus B is equal to C. Pag mag-a-add tayo ng matrix, first sa matrix A, first column, first row, saka sa matrix B, first column, saka first row. 4 plus 0. 2 plus 1. 1 plus 4. 3 plus 8. And so on. Katapos naman ni add yun, kukunin na natin yung sagot. 4 plus 0 equals 4. 2 plus 1 is equal 3. 1 plus 4, 5. 3 plus 8, 11. And so on. This is the final answer. Another example tayo, subtraction. Ganun lang din yung procedure. Pag same ng column saka rows, dapat yung column ng A saka B parehas. Kumbaga 5x5, kailangan 5x5 din yung isa. Pag magpa-minus, ganun lang din sa ganun lang din sa procedure na nag-add tayo kanina. 6 minus 7. Yan. 2 minus 2. 5 minus 1. 3 minus 3. And so on. Kunin natin yung sagot. Let's subtract A minus B. 6 minus 7 equals to negative 1. 2 minus 2 equal to 0. 5 minus 1, 4. 3 minus 3, 0. 1 minus 1, 0. And so on. This will be the final answer. Product of matrices. Besides adding and subtracting whole matrices, there are many situations in we need to multiply a matrix. by a constant which called scalar, we call that a scalar is a real number. Quantity that has magnitude but not direction. For example, time, temperature, and distance. The process of scalar multiplication involves multiplying each entry in a matrix. Scalar multiplication in distributive. Sabi dun, ito yung scalar, yung constant. Multiply siya dito sa each entry or elements. 2 times 1, 2. 2 times 2 is equal to 2 times 3, and so on. Okay, let's multiply this to get the answer. 2 times 1, 2. 2 times 2, 4. 2 times 3 is equal to 6. 2 times 4 is equal to 8. This will be the answer. Another example. 4 times 2 is equal to 4 times 2. Distribute lang natin ito para makuha natin. Same procedure lang din, gaya ng ginawa natin doon sa naunang example. 4 times 2, 8. 4 times 3, 12. 4 times 5, 20, and so on. This is our answer. Let's proceed to multiplication of matrices. Matrix multiplication A times B or AB is defined if and only if the number of columns of A is equal to the number of rows of B. Such matrices are said to be. Pwede lang daw i-multiply kapag yung rows ng A is equal to column ng B. And itong column ng A saka rows ng B yung magiging sagot. Unlike kanina, distribute natin yung constant. Ito naman, yung column ng A, rather, yung rows ng A, ito, multiply natin each column of B. Gaya nung gawa ko dito. 4 times 3, 6 times 4, 8 times 2, 1 times 1. Ito. Dire-diretso lang. Tapos, pagkatapos natin i-multiply, we can add to get the answer. 12 plus 24 plus 16 plus 1, 53. 20 plus 18 plus 8 plus 4, 50. 8 plus 30 plus 56 plus 6, 100. This is our answer. Okay, let's proceed to our next topic, methods of evaluating determinants. There are 5 methods of evaluating the determinants. Number 1 is basket weave method. Number 2, minors and cofactors. 3, pivotal element method. S method, upper triangular elimination method. Number 1, basket method or spider web method. May example ako dito. Let A be a square matrix of order 4 given by A is equal to 4, 3, 4, 5. 1526 to 424. First, can multiply the diagonal. 4 times 5 times 2 times 5. You get 4 times plus next diagonal 3 times 2 times 4 times 3. Third plus 4 times 6 times 2 times 1 plus multiply by 5 1 4 3 minus, kasi dito naman tayo sa kabilang diagonal, 5 times 2 times 4 times 3. 5 4 times 6 times 2 times 1 3 times 1 times 4 times 3 4 times 5 times 2 times 4. Then pag nakuha na multiply na natin kuha na natin yung answer. 4 times 5 times 2 times 5 is equal to 100 plus 8 times 2 times 4 times 3, 72. Pag nakuha na natin yung multiplication niya, i-add na natin. So 200 plus 72 plus 48 plus 60, 380 minus 120 plus 48 plus 36 plus 200 is equal to 404. Then we can subtract to get the final answer. A is equal to negative 24. This is our answer. Another example. B 1 3 4 5 6. This is 5 by 5 matrix. 5 by 5. Kinuha natin yung apat na column. Ito. Pinagdag natin dito. Ito yung kinuha natin. Ito. Pababa. Column. 1, 7. Ganun lang din yung procedure kanina. Minultiply ko lang diagonal. Nakakuha ako ng 40 first diagonal, 72 plus 256 plus 7. Then saka ako inad. Then saka ako minus. This is the answer, 1146. Minors and cofactors. What is the minors and cofactors of A11? A11. Cofactor ng A11 ay ito ang cofactor. Cofactor ng A11 at ito ang minor ng A11. Cofactor. Ito is the rows and columns. 1 plus 1 is equal to rows and columns. Ano naman daw yung cofactor ng A12? A12. Simply negative 1, 1 plus 2 minors niya ay neglect natin to. Ito A21, A33, 33 diagonal minus kabilang diagonal naman A23, 23, A31. Again, this is the minor. This is the cofactor. Ano naman daw yung minors and cofactor ng A13? A13. Simply 1 plus 3. Ang minor niya ay itong natira na to, A21, A32 minus A22, A31. Kunin natin yung minors ng A21. Minors ng A21 is neglect natin to. Saka ito A12, A12 nice, A33 minus A13 minus A32. GS method. May example tayo dito na 5x5 matrix. 5x5. 5. Maganda dito. Mas magandang example ng GS method ay dapat 1 yung first column. Ang gagawin natin dito ay mag-interchange tayo dun sa third column. Papalitin natin sila. Ito na interchange ko na dito. Since nag-interchange tayo, ilalagay tayo ng negative sign dito. Then proceed na tayo dun sa 1 over 1. Since 5x5 matrix yan, 5 minus 2. 2 is a constant.